G'day team, welcome back to another video. So today we're going to be looking at compound interest. So extending on from the last video where we looked at simple interest, we're now going to be looking at when that is actually compounded annually. So as always, this is a part of the Hazy 12 General Textbook and we're going to be looking at chapter 7b.1 if you would like to follow along there. So unlike simple interest, where the initial value is always used to calculate interest annually, the compound interest, so with compound interest, the total at the end of each year is the new initial value, okay? So it kind of looks a bit like this graphically. So if we're looking at simple interest, we have a linear relation, okay? We're adding the same amount of interest every time, but with compound interest, we actually have this exponential growth, okay? So over time, that growth is going to get larger and larger. And you can see how the value increases more over the same time period with compound interest, all right? So I've tried to line these up as best as possible, but if you're looking 3 units across, we can see that it's about 2 2/3. 3 units across, we're at 3, all right? So we are actually increasing faster over time. So we're going to actually look at where the formula comes from. So the best way to do that is having a look at an example. So suppose $3,000 is invested at 6% per annum and the interest is compounded annually, okay? So with these questions, please make sure you are checking if it's compounded interest or simple interest, okay? It's really key to make sure we're reading the questions. So after 1 year, the value equals $3,000 times by 1.06, okay? So if we just times by 0.06, like the 6% would indicate, we're actually going to lose money. So we need to times by 1.06 as 100% becomes 106%, okay? Because we're increasing by 6%. After 2 years, okay, we have our value after 1 year, $3,000 times by 1.06, and that's times by another 1.06. So hopefully you guys remember, anything multiplied by itself is a square, okay? So $3,000 times by 1.06 squared, okay? After 3 years, we take the value after 2 years, so $3,000 times 1.06 squared, times by another factor of 1.06. What we do with our indices when we're multiplying numbers with the same base, so we add them. So $3,000 times by 1.06 to the power of 3, because we've got an index of 2, an index of 1, we add them together to get 3. And this will continue on for as long as you want to keep calculating this compound interest, okay? So for these types of examples, we can construct the following formula. So the future value of an investment with interest compounded annually is F of V, so future value, is equal to PV times by 1 plus I to the power N, okay? Where PV is the present value or the amount initially invested, okay? So it's either the amount that was initially invested, or if you're looking from a certain time period after 2 years, PV would be that value after 2 years. I is the interest rate per year as a decimal. We want it in decimal form, not percentage form. And then N is the number of years. If you're given, so for now, we're going to calculate annually, so we're going to leave that in whole numbers, okay? So example 1, so this is a very common question that you would get about compounded interest early on. So $4,000 is initially invested for 8 years at 4% per annum compounded annually. So again, really looking at the wording of the question to see what we're actually going to be looking for. So this is split into 2 parts. What will it amount to at the end of this period, it being the value of the account, and part B, how much interest is actually earned over this period. So part A is where we whip out our formula, so FV equals PV times by 1 plus I to the power of N, substituting in our values that we know. So we know PV the initial was 4,000, the interest rate was 4%, so 0.04, and the amount of time was 8 years. So we've got an 8 up there, and that is equal to approximately 5,474.28. Therefore, the investment will amount to $5,474.28. Please make sure you are rounding to 2 decimal places. When we are working with cents, we have 2 decimal places. So notation-wise, always round to 2 decimal places. Part B, the interest earned over that period. We take the total value of the account, take away the initial value that was invested, and we're left with the interest earned. Okay, so $1,474.28. All right. Example 2. So this is finding the final value. Another type of question is you're going to be given the final value and you need to find either the initial amount that was invested, the interest rate it was invested at, or the time it was invested for. So we're going to run through an example of this. So Mr. Virgo, myself, I invested a sum of money at 7% per annum interest, and that was compounded annually. After 5 years, the total in my account was $10,519.14. How much did I initially invest? All right. So I would start by writing out our equation, okay? F of V equals PV times by 1 plus I to the power N. And then we just substitute in the information that we know. So we know the final value of our investment, we know the interest rate, and we know the time frame. So we can substitute those 3 values in. What we want to do now, we want to solve for that initial investment. So we will need PV by itself on one side of our equation. We are going to do this by dividing both sides by this 1.07 to the power of 5 on both sides. So we're left with PV equals 10,519.14 divided by 1.07 to the power of 5. If you put that into your calculator, you'll see that PV is approximately 7,500. And then we just finish our question with a statement. Therefore, Mr. Virgo made an original investment of $7,500. Okay, make sure we are always stating our answer at the end, just like with our linear programming, just like with matrix programming. Okay, it's really important to state that answer with all of the relevant information. Okay, so the process in example 2 can also be used to solve for I and N. Solving for N is a little bit trickier, and a useful tip when you get to that point is remembering that A to the power of 1 over K is equal to the kth root of A, okay? So a base to the power of a fraction, all right, is the denominator comes down as the root, all right, and we take that root, all right? So that's a little bit of a useful tip for when you're solving for N, all right? Please have a crack at the questions in 9B.1 and 7B.1, and we will see you guys next time.